Hi, Michelle. How are you? Okay, good. Okay, so today we're going to cover lab 14, which is our last lab in the semester. And in this one, we want to focus on encryption and steganography. So I spent a little bit of time debugging some of the issues with the package. So let's talk about that. You can find the lab in Canvas, and it's on the assignment here. You can download the document. So in this lab, we are going to do the exercises in Debian Linux. You can use Ubuntu or Kali. I mostly use Ubuntu this semester, so we're going to use various modules. We're going to use cryptography module, Fernet, and we are going to also use PyCryptodome along with Stegano and Stepic. Okay, so I want to touch on these modules because you likely will see the tools being used for cryptography with the implementation of these packages. So to start, we're going to start with part A. And in part A, we are going to use cryptography module. And in the past, you probably have seen an exercise or have used the module for other purposes. So this is going to be high and low level. Cryptography is very common for Python. It allows us to implement symmetric ciphers, message digest, and key derivation so we can generate key for various algorithms. Now, in the textbook, it talks about using secret and the library to be able to generate key. However, since we're using cryptography, we can definitely incorporate Fernet with it to be able to generate keys. So Fernet allows us to make sure that our message is encrypted and the key is not manipulated, especially for symmetric algorithm. So you will need to log into your Debian Linux system. And after you do that, you can start with installing cryptography if you haven't. Now, when you do this later on, you will find that sometimes when you install cryptography package and you need to install PyCryptodome, it would place the additional modules for PyCryptodome inside cryptography, as originally this is going to be the package that's often used for encryption. So we will need to run a few things in order for PyCryptodome to work. So what we're going to do is we are going to make sure that we install cryptography. So let me see. And with this, let me see if I can zoom in a little bit here. So we would simply do a pip3 install cryptography. And since I have done that previously, it showed that my requirements are already satisfied. However, if you haven't installed it, you will see that it's going to download and install. And after we install the package, we would create a file, and we can simply use a text file, or if you already have a file, you can also use that. But in the next step, step 3, I simply use an echo, and I want to append text. So this is my secret file. And we want to point it to our secret.txt. And I'm going to make sure that it's different than the one I already have. So I'll just name it secret1.txt. And if we want to check, we can simply do an ls. And so here we can see that, let me scroll up. This is my text file that I just created. And you simply want this file to be in the same directory as your script, of course, so that way we can encrypt it. So let me clear. So after you have created a file, you would then write your script. And we would use Nano to do this, or you can use another text editor. So I'm going to go ahead and explain the script as I already have it written. So Nano, and I call this encrypt file.py. So in this script, not too long, we are going to make this an object-oriented program. We are going to use Fernet. We're going to use the cryptography package in the Fernet module. We define a class called encryptor, and in this class, we have methods that would create key, write key, and load the key. So initially, you need to create a key, and Fernet is definitely useful for that. So in the class, we have the members key create, key write, and key load. And in the method or the function, we would have the object key. And this is a Fernet class object, so we instantiate the object. And we want to use the generate key method, which comes with the module, to create your key. So the first step is to create your key. Now, once you have the key created, we want to store it. So we would store the key. And so in the next method, we have key write. And for this particular method, we are going to use with open statement and be able to store the key. Then once we write the key, and in this one, as we write the key, you simply use the write method. And so here we would have with open and then your key name. And we would use WB for write. So that's going to store. And then it's going to write it as my key. And so after that, we would use my key to access the attributes or the method write to be able to store our key. After we have written the key, we would then load the key. And so we simply define another method called key load. And in this method, we are again going to use with open statement. And here, when you load the key, you simply have it read the key. So you are going to, the second parameter for this is going to be RB instead of WB because you already wrote the key. Now you want to read the key. And with that, we are going to use the read method and we're going to return key. So let me go down further. So once I have the key set up, I have another method called file encrypt. And in this method, we are going to instantiate the object F, which is going to be used for, this is instantiated for the Fernet class, and this is going to be used for the key. So then what we're going to do is we are going to use that key to encrypt the file. So we are again going to use the with open statement and we're going to read. So we're here in the parameter, we're going to do RB and we're going to read the original file. Then after that, we are going to have an object called encrypted. And for this, we are going to encrypt the original file. So it's going to store the encryption for the file. And then as we've done that, the second part of this is to write it to a file. So we want the file to be separate. Let me see what's going on. Okay. Okay. So make sure that you have, let me go up. Yeah, make sure that you have the colon and then all the members are properly indented. So make sure that we indent in the sub and then for the class, it's just going to be not indented. Okay, so after we read the original file, we then would use it with open statement. And in this one, we want to bring down the encrypted file. Okay. And with the encrypted file that was from the previous section up top. So now we're going to write it. Okay. And so with that, we're going to use the write method. And it's going to be writing the encrypted file. And then lastly, we would have the decryption. So we have another method called file decrypt. And again, similar to the encrypt, we are going to instantiate an object called F. And we want to use that object for the key. And we are going to implement with open statement. Now with open, you want to, for the parameter, you want to put the encrypted file. So it's going to read the encrypted file. And then it's going to decrypt. And then it's going to write the decryption to a file. So that way you can see the plain text. So the process is that we would create the key, right? Store the key. and read or load the key. Then we would use the object to be able to bring the key, and we would use that for the encryption. So when we encrypt, we need to read the file, and we are going to then write the file as it's encrypted. For the decryption, it's the same. It's going to use the key to read the file and then store the decrypted file. So for the bottom, we are going to, after the methods, we are going to define encryptor as an object, and this is instantiated for the encryptor class. Should not be indented. Oh, I'm sorry. Yeah. If it was indented, I had to fix that real quick. Let me see. Yeah, sorry about that. This should not be indented. Oops. Okay. So for that object, no indentation there. Because if you indent it, it's going to think that it's part of the class. So this is going to be global. Okay. And then we are going to define another object called myKey. And here we are going to call on the method keyCreate. And we simply use this method as attributes for the encryptor object. And then again, we are going to call on the next method, which is going to be keyWrite. And here in the parameter, you want to pass key and myKey.key. So as it's storing the key, right, it's going to be using myKey.key. And then to load the key or read it, right, we are going to bring down the myKey.key and use it as the parameter as we defined the loaded key, and you are going to use the key load method. Okay, so key write, key load, key create, key write, and key load. Those are the three methods that we previously defined as members of the encryptor class. And then to encrypt your file, we simply call on the file encrypt, which is a method that we defined in the class. And for the parameter, you have to load the key. So you are going to bring down the object loaded key that you previously defined on the last line. And we want to put it onto, we want to use the file that we create to encrypt. So we're encrypting this file. This is our target. And then let me scroll right here. We want to output it to the enc_secret.txt. So you want to save it as a second file that would be encrypted. So you can see the difference. So the original file is secret. The new output file is going to be enc. Incorrect padding. Invoke token. Okay. So that means that it's not, when it says invalid token like that, maybe it's not able to read the key, but if it encrypts your file, then it's loading the key fine. Were you able to get the decryption as well? So the last part here is the decryption. So we are doing the same similar approach to the last line where we would, but for the parameter, we would use the encrypted file, and then we're going to output it to the decryption file. which is the DEC secret. Okay. So after you finish your script, you simply run your script. Oh, I apologize. I think this is an error here. Okay, so go back to your script and you should pass this as ENC. Fix this part right here. On the last line, it needs to pass the encrypted file to output the decrypt file. And then run it again. I forgot to fix that when I uploaded it. So, yep. So the whole point is that if we're encrypting the file, we just simply use the original file in plain text, put it in as a second parameter for the file encrypt. That's a method we define, and then we want to output it as an encrypted file. Then when we decrypt, we simply take the encrypted file, we load the key, we use the encrypted file, and then we output the decryption. So, and then when we run this, right, we would have the decryption. And so you can check by doing ls, and you would find that here is for our secret, this is the original file. And then for the encrypted file, it's right here. And then for the decrypted file, it's above right here. Okay, now we can go in and we can take a look at the file. So if I nano in to the ENC secret.txt, I would see that it is non-readable. We can't read this because it's encrypted. And then if we nano in to the decrypt secret.txt, we would see that now it outputs it as a plain text. So when you do the encryption and the decryption, you start with the original, you save the encrypted file as a second file, and then you would save the decryption file as a third file. You can convert that file to the original file, but we want to see it in stages. So that way we know that our script for encryption and decryption works. So in that, with that, we would see that. So next, take a screenshot of your output. Right, simply it just ran the script. It shouldn't give you any error if we fix this. And then you should be able to see your encrypted file and your decrypted file. And you can go into it. So the encrypted file, it doesn't match your plain text, of course. You would have different scrambled text there. When you go into the decrypted file for step 9, it should match your plain text from step 3 so that we know that it works. Now, coming back to the script to answer 9B, right? We would see that Fernet plays a big role in key generation. So the methods that you implemented for key generation, key write and load. So we store the key and we read the key from where we store. This is where we would use Fernet. Now for cryptography in general, in order to use Fernet, we have to bring in cryptography package. And as it is part of that package. And then in the encryption, we would, because we're using the key, we would then have to instantiate the key object. And so for both encryption and decryption, Fernet also plays an important role there. And cryptography also allows us to access, right, the files and read the file as it would apply the algorithm there. Okay. So as you can see, we're able to do that using cryptography package. Any questions? Now, I went back and forth trying to debug some of the issues that PyCryptodome has. So depending on the version, I think that on the build for Ubuntu, it requires additional package. Okay. We already installed cryptography from the last exercise, so you don't have to do that. But when you're using PyCryptodome, because it is low level, you need GIMP or you need GMP to be able to build out or to build the actual interface between your system and the low level. So now when you install PyJWT, if you install cryptography, it might already been there. So all else, I just want to make sure that we have all the things that we need. Also, it's very important that you push update, even though it does take a little bit of time. But if it is not updated, it won't be able to bring in all the submodules for that package. If you have issues, what you can do is you can try to uninstall and reinstall these packages, because sometimes it doesn't place the submodule in the right crypto directory, so it's not able to pull the package or the submodule from the package. And I read through their documentation, and I have to kind of dig around and find some information. So, you know, after about 10 steps back and forth fixing the issues, I found that this actually worked for me. Okay. So we can take a look at the installation here. So let me size this down. So we'll start with pip3 install PyJWT. And then we would do sudo apt-get install build essential and typing in libgmp3 f, and this is going to be for Python 3. Now keep in mind that these packages were originally written for Python 2, so they have upgraded it to be able to work with Python 3. So we want to make sure that we have the proper tools there. And then I already did cryptography in the last one. So now I can do pip3 install PyCryptodome. And you can always check the version. And then for Ubuntu specifically, the next step is important. And also if you read the documentation, they show you how you can test it. I simply just try to import, if it's able to import the sub module, then it should be fine. So we would do a pip3 install PyCryptodome X. And then we would do sudo apt update. So the update part might take a little bit depending on what packages you have installed. So I have 90, so it took a few minutes or a minute or so. So now we're gonna invoke Python 3. We want to test it in shell, so we would do the import statement to see if it worked, because you don't want to try to write your script and then the packages are not in its appropriate places. So here we simply want to import in AES, as we are going to work with the algorithm with PyCryptodome. So if it took the import statement fine, then that means that it builds fine and able to have the proper submodule used for your script. And then I'm going to test the next statement. So crypto.random. This is where we are going to use the get random bytes to generate the key. And we can specify the size of the key here. And so I know that it works now in shell, so it should be working in for my script. Okay, any question? Now if you visit their documentation, you would find that they did show some resources here, okay, on how you can use this. And if you click installation, and I would check this as they update the module, they show you how you can bring in the package for testing, okay? And then if you scroll down, it talks about how you can compile it in Ubuntu, because this is written in C, so it has to build in the Linux OS. So you would need the build essential for Python there. Okay. So now in the next step, we are going to write a short script. We are going to encrypt the file using AES algorithm. And we are using PyCryptodome package for the encryption. Okay. Now from this script, what we're going to do is we are going to first, set up, let's let me go in and I'll pull up my script. So you can use nano or text editor AES encrypt.py. So I have two import statements. I'm going to use crypto cipher that was from Cryptodome and crypto random. So cipher is going to allow us to implement the algorithm AES, and for the random, we're going to use get random bytes for the key. We define the object data, and this is where we would set our secret data. So your plain text goes there. And for the key, we are going to use get random bytes, and here we would specify your key size. So that will be 16 bytes. And you can go higher than that, right? And you can look at specification for PyCryptodome on what parameter you can use. And also our notes, we touch on that too for the lecture. Now for the cipher, since we're doing AES, we're going to use AES and we're going to construct. So this is C-based, so we're going to use a constructor to create the key. And for PyCryptodome, unlike cryptography, you have to specify the mode. So here we're going to use EAX. And then for our text, which was defined up there, we're going to set up the tag, and this is going to be for, we are going to use the message digest. So this is going to take the plain text and be able to apply the algorithm. For the output, we are going to put the encryption into a file called encrypted bin, encrypted.bin. And since it's outputting to a file, we're going to use WB for write. Next, because it's going to stream out, right? So we are going to do a file out.write, and we're going to use a loop to be able to output your ciphertext to the file. So let me scroll down. And then lastly, we're going to close that file. So in this script, we simply just output the encryption into a file, and we apply AES algorithm. So after you have your script, you would run